All right, Lady Ada, what is this?
Hey, everybody, and welcome to Show and Tell. Sometimes we have guest hosts, but not today. Today we have us, me, Lady
What is
Ada,
this?
Mr. Lady Ada, checking in with people around the maker community, including Adafruiters. What are they up to? What are they crafting? What are they soldering and coding and sewing and more? Other people are also, of course, welcome. We're here for about 25 minutes. Come on by. We're in Discord, discord.gg/Adafruit in the live broadcast chat, and you can join up. You just need a webcam. Everyone has a webcam these days.
Here is your chance to also see some of the behind the scenes things that we're working on at Adafruit, exciting stuff, kind of top secret-y and more. Scott, what are you working on right now?
Hello. I am working on BLE on the Expressif chips. And next to me, I've got a C6 Feather running. And one thing I wanted to show is this is the File Glider app. I've been working on getting the BLE workflow working. One thing that's cool, though, is that it's actually showing both the Wi-Fi workflow and this is the C6 on the BLE workflow. So I think if I can interact with it here, and then I go down to load the files, and there we go. Those are the files loaded from a C6 Feather, and I can...
So you're browsing a remote file system.
That's right. This one's over BLE. So this is just, I was testing ePaper with it because I fixed an ePaper bug. So this loaded the code from there, and I can save it if I want to, but this is BLE workflow working on the ESP32C6. At the same time as, should we see if I can push the demo here? Can we go to the Wi-Fi version and load it over? Oh, could not complete. Didn't work over Wi-Fi, but we're getting there. Yeah, BLE and Wi-Fi at the same time.
All right, exciting.
So because this board has both, that's why we're allowing both. Is there any other way to do this? Because this is, I know we're doing this because it's like nearly impossible. Like how would you do this other ways? I guess you could have a separate app or
I don't know of another way.
Yeah.
Like there's no standard for transferring files over BLE.
Yeah.
What our approach right now, because the C6 doesn't have native USB, our approach right now is that you have to use like the serial terminal to set your Wi-Fi credentials. But what I'm working on right now is if you don't have Wi-Fi credentials on the board, it will also broadcast or advertise as BLE, so you could use your phone to set those credentials too if you wanted to.
Yeah. This is so complicated if you don't do it this way. So I was just trying to think, is there any other way that I would be able to go into remote file systems on microcontrollers with the
phone?
With a phone.
I don't know.
Yeah. Okay. No. Well,
it's not simple. It makes me appreciate how much USB was done for us.
Yeah. Well,
showing up as a drive was like great. Everything supports it.
Yeah, we're basically making like a fake USB in the air. So that's kind of cool. All right.
Yeah, and I talked about all that at Pi Cascades. I don't know if the video is posted, but if folks want to know more about our different workflows, that
kind of reminds me of the magic when, like, back in the day, you would like connect to a network and like double click on a drive somewhere else. It's just like, how is this possible? It's kind of cool. It was that easy, dragging, dropping files. Okay. If folks want to learn more about this, they should stop by and see you on Friday at
2 p.m. Pacific.
2 p.m. Pacific.
Yeah, I'll be working on some of of this stuff, and we'll see how far I get. I had to disable the security part to make that work, so I've got to figure out why that's working.
Okay.
Alrighty, thanks, Matt.
Thanks.
All right, Jeff, show us something cool.
Hi there. So I've been working on streaming MP3 playback, and here's my test board. It's a Metro with ESP32S3. It's going to go on the Wi-Fi, download some MP3, and stream it right out the I2S controller. So I'm going to turn that on, and I apologize that the material is a little bit dry because finding a royalty-free stream that is also not on HTTPS that we can just play. So this is the CircuitPython weekly meeting.
Weekly meeting for June 3rd.
Yay!
2000.
So yeah, that's our very own Tim doing last Monday's CircuitPython weekly meeting, which is one of these things we do in public and share with everybody about what we're doing in CircuitPython. And it was, streaming it directly from Amazon S3 decoding the MP3 here on the Metro and playing it out the I2S. So I'm really excited that is working. I got over a number of problems in the last couple of days, but if you want to bring up my screen share, I'll just walk you through what it's like to do that. We have, of course, all of our imports at the top, but then we can just set a URL, and if our URL starts with HTTP or HTTPS, we're going to get that via requests, and we have to request it's a connection : close, so that the socket isn't waiting out there for us to give another request, so we know when it's done. And then the rest is pretty standard for audio. We create our I2S output device. We create our MP3 decoder. This one is going through the audio mixer, so you would be able to adjust the volume down if your MP3s are too loud. And then it's just like an MP3 off of the file system or an SD card. You just say play. So that is how it will work once this open pull request gets merged, hopefully in the next couple days.
Neat. This is cool.
Alrighty.
I mean, like a lot of people are like, but like Python isn't nearly as fast or powerful as C or C++. But this is like a pretty challenging amount of computation. You have the REPL loop running. You're streaming from a socket, hopefully also soon an SSL socket. You're working on that next.
Soon. Put in an issue to enable that. Yeah.
And outputting it to I2S. Like there's a lot. And you can also do mixing. And you can also do like pause, replay, all sorts of stuff. And yeah, I don't know. It's neat. One thing that I asked you to do like later on is maybe also do ID3 DAG decoding. So you can.
I think that will do in raw Python.
Yeah.
I'll have to figure out exactly how that works, particularly with streams. But that's like file parsing and things that Python will do pretty well. But the decoding, you definitely have to have that C code. And we actually share that C code with Arduino. So it's relatively battle tested.
Yeah.
I will caveat that, like, if your Wi-Fi is not super reliable, the audio will stop and it will like come back 5 seconds later or 10 seconds later. But that's your Wi-Fi, and that's kind of separate from whether the rest of it works. And the rest of it works. So
I mean, amazing. It's a $2.50 microcontroller.
Mm-hmm. Yep.
Very impressive. This used to require like a single board Linux computer.
Yeah.
Cool.
Not anymore.
Okay.
All right.
And,
win amp.
Yeah, we'll be able to do that. So if folks want to play around with this, where, if, and when could they?
So on GitHub, there is an open pull request, and you can go to that pull request and download what is called the artifacts and get a UF2 file or whatever kind of file to install on your device. And I've only tested this on the S3s. We like that because it has the dual core. The Wi-Fi is actually operating on the other core from CircuitPython.
Yeah.
It might work on some other microcontrollers, but right now the S3 is the one that we're really focusing on.
Alrighty. Thanks so much, Jeff.
Thanks, Jeff.
All right. See you around.
All right, Liz, what's going on?
Hey, so this week I worked on a product guide for the new Pixel Trinkey, which I have set up behind me. You can see in the corner there. And one demo I wanted to try, because with the SHT45 Trinkey, we did some demos with CPython where we had a COM port connected to that Trinkey, so we were able to log data to Adafruit.io with our computer, even though it doesn't have Wi-Fi. So I wanted to see if I could do something similar with the Pixel Trinkey. So right now I have the Pixel Trinkey running some Arduino code that's listening for color codes over a serial port, and then I have a Python script that's connecting to Adafruit.io, and it's listening to this feed. And when I update the color and send it, it takes the color or the feed, reconfigures it so it's in the format that the Arduino code that's running on the Trinkey can read, and updates the color.
Nice.
So that's a little demo that's in the guide. And so if folks want to like control NeoPixels connected to their computer over Wi-Fi, they can totally do that.
Okay.
Yeah.
Alrighty, thanks so much, Liz. And I assume there'll probably be some guide-like thing or something one
This was
day.
in the guide already.
It's already in the guide.
published.
Yeah.
Already
Published.
published.
So there's
So
a
folks-
UF2 you can drag and drop into the Pixel Trinkey, and there's just a CPython script you can run locally on your computer and just put in your I/O stuff.
So folks can go to learn.adafruit.com, and you can also make a free io.adafruit.com account to do this. You do not need to use a Plus version unless you want to support us at some point, but you can do all this for free.
Yes, exactly.
All right, thanks, Liz.
Cool. Have a good one.
Alrighty, JP, what you got going on?
Hey, what I got going on is the, speaking of Trinkeys, I've got the TRRS Trinkey plugged into one of these Xbox adaptive controllers. And we've got a guide out. I'm going to add a guide page that shows how to use analog joysticks with this. So this is designed to have USB joysticks, like flight sticks, plugged into the sides to act like your thumbsticks, but those can be configured into sort of any physical form that's easy for a particular user to use. I've just got one of our little breakouts for thumbstick here, and you can see on my laptop here I'm running just the menu select screen for Overcooked, which is a nice low stress demo to show this, unlike the game, which is huge stress. And you can see here I'm able to add a analog control with just this little gizmo right here. So we've got the tip ring and sleeve of a TRRS cable that one of our puppies chewed on at one point, but it still works.
Delicious.
And it must have felt good on their teeth.
Puppy-proofed electronics.
It is. Imagine that. It still works. When we plug this in, we're able to get on, I've put voltage on tip and ground on sleeve, and then the two rings are acting as analog ins on this little M0 chip on here. So when I plug this in, it essentially enumerates as a USB joystick in the form that this Xbox adaptive controller wants, and then I'm able to use that. So this has,
I think before people would take like off-the-shelf controllers and then try to like modify and mold them, which is cool. But this, if you want to make like a long stick or like a tongue interface or like a chin interface or
you can hook sensors up to it. Also.
A foot interface, it's like you don't have you don't have to take a $50 controller. You can take like a $3 joystick.
IR.
Yeah, you can do a lot.
Yep, any way you want, and you can have, the nice thing with these pretty standardized plugs is that you can then have multiples of them that you can just plug in, and it pretty much just works as soon as you plug it in. So you can have different controllers for different games or for different users without spending a ton of money, and you can customize it, like you said, into any form you want. So I'm going to show this and a couple of variations on analog inputs for it on my workshop show tomorrow, if people want to come by and check that out. And then I'm going to write up a quick guide page, which will also serve as a guide for people who want to use pretty much any analog inputs for the thumbsticks on the Xbox adaptive controller.
Yeah. And as usual, since someone had asked in the chat, learn.adafruit.com has all of these or soon. So
this is coming in a couple days.
Yeah.
You just it today.
Learn.adafruit.com and then adafruit.com for
And the guide for this is out already, so you can learn about using buttons with it, and soon we'll have some of these joystick things as well.
Okay, cool. All right. Thank you so much, JP, and see you tomorrow on JP's workshop. We're going to go to Flying Things next, and then after that, we're going to go to Mark. All right, Flying Things, take it away.
Hey.
Hello, can you guys hear me?
Yeah.
Awesome. Hello. I've added some more speakers. So I had some added speaker in the forehead that was not good. I added 2 more speakers. Well, I changed it out for 2 speakers in the ears, and they're not visible because they're covered by the fabric, but I can play noises and sound effects.
Oh, wow. That's nice. It's like, built into the glove. So it's like you don't even have to like get your phone out or anything. Are those conductive pads? How are you detecting the switches?
Yeah, so these are conductive pads that just contact each other.
Oh, it's so cute. I just love those toe beans.
Thank you. And I've had an idea about doing a capacitive touch so I can interact with other people, but something I'm still working on it.
Oh, what'd be interesting is, because you're like touching your face, it'd be cool if you had little capacitive pads like on your nose. And when people touch it, your eyes change or like, you make a sound effect. So that could be a good idea too. Or people high five you. Because you can them. Yeah, and be like, high five.
I do have a button. I'm not sure if it's very audible. I have a button in the nose, but it's not connected to anything.
Okay. Well, I'm ready to boop you.
Perfect. And one last thing is I have a microphone to project my voice, so it's not just this microphone here.
Yeah.
So that, you can kind of hear the feedback. So these are coming through the speakers now to project my voice out so people can actually hear me.
That's a great solution to a common problem when you're wearing a mask. You're so muffled. So yeah, that's so good. It sounds great.
Yeah, thank you.
Looks good, sounds good. Thank you so much for showing this project. I know you've showed a couple variations of parts of this project as you've been working on it, and it looks great. Keep coming back.
And I love, you can tell you've done a lot of practice with all the motions and like what your face is gonna look and how you like move your body. It's like puppeteering is so hard.
Yeah.
But I can tell that you do a lot of practice in the mirror. Like, okay, what does it look like? How should I move to make it look so natural?
Yeah, definitely.
All right, thanks so much.
Okay,
thank you
so much, Flying Things.
All right, Mark, play us out.
Why aren't you as cute as Flying Things?
Oh.
I was thinking the same thing. Unfortunately, I don't have anything quite that bright tonight that's flashing and making sounds.
Maybe next week.
Yeah,
I'm still
what you got going on.
I'm still playing with magnets. So not as bright as LEDs, but after last week, and using the TLV 4930, I had also at the same time ordered some chips that is the MLX 90316. They're very similar to read what's going on with the magnet, and I'll just quickly show it. So right now it's only running on Arduino. There's a reason for this, but the chip itself will change the magnetic field into the rotation angle. So it just removes a step, makes it very simple for telling with a fairly high degree of precision for where you've how much rotation you've got.
Mm-hmm.
The big downside being is these things are about 3 times as expensive as the other chips.
Yeah.
I will quickly take this out of its enclosure. And see if I can focus. There we go. So what's interesting about this chip I found is that it's a single data in, data out for SPI, which I did not expect and did not plan for. So it became a real challenge in figuring out how, and that's why it's running on Arduino right now. It has to bit bang to the chip itself. There is a way to switch between them using a MOSFET, but I do not read data sheets very well, apparently. So without knowing that,
you get a chip and you're like, this is the perfect thing, and then you're like, oh no, it's 1.8 volts. It's so common.
Yeah, and now, so I might continue playing with this. The TLV chip is a lot cheaper, so I might just use that myself. But what's interesting is this chip is actually 5 volts, but is running fine on 3 volts.
Oh.
So I might be able to drop the regulator and instead just put in a MOSFET and associated components just to split it into the 2 data in, data out pins. But it's a very interesting chip. For the same purpose, it just removes some of the complexity of taking magnetic fields and converting them to angles. So,
okay,
very cool.
Really, just experimentation this week.
All right, good learning.
Good stuff and good progress. And then in the chat they mentioned this 3D Mac could use maybe your idea about the media controller with a round screen in the center.
I don't remember my idea, but yeah, totally.
Yeah, this would work perfect for that.
Time is an illusion.
All right. Well, thanks so much, Mark.
All right. Thanks, Mark. Okay.
All righty. That's our show and tell for the week this week. Thanks for making this the best half an hour of our week. Every single week. We'll see everybody back next week, 7:30 p.m. Eastern Time. Ask an Engineer starts in a few minutes.
Bye, everybody.